Hey guys, welcome to Learn Today IGCSE. This is a tutorial video for Physics, Paper 6, Variant 6-2 for May June 2023 examination. Question 1. A student investigates the stretching of a spring. Figure 1.1 shows the setup. Okay, I would suggest you guys to just take a minute to understand the setup of the experiment before proceeding to read the rest of the question. You have a clamp stand holding the spring and a meter ruler to show you the extension of the spring, all placed on a bench. Question A. The value L0 is the length of the spring when the load L is 0 newtons. The student measures the length L0 of the spring. She records L0 equals to 16 millimeters in table 1.1. Draw a diagram of the spring to show clearly the length of L0 of the spring. Firstly, let's draw out the spring from the diagram. You are required to show clearly the length of the spring without any load. This means that you should measure by taking the top to the base without including the hook of the spring. This is the only part of the spring that will extend when the load is added, therefore we can label this as L0. Question B. The student suspends a load L equals to 0.2 newtons from the spring. She records the new length L of the spring in table 1.1. She repeats the procedure using L equals to 0.4 newton, 0.6, 0.8 and 1 newton. The readings are shown in table 1.1. Question 1. Calculate the extension E of the spring for each load using the equation E equals to L minus L0 and record the values of E in table 1.1. And part 2 of the question, complete the column headings in table 1.1. To get the value of E, we can use the formula L minus L0. The value of L is already given in this column of the table, and we know that L0 is 16 millimeters. We can now proceed to complete the column headings. Question C. Plot a graph of L y-axis against E x-axis. Draw the best fit line. Okay, first let's draw the x and y axis. Your x-axis is the extension of E in millimeters, and your y-axis is the load in newtons. Always don't forget to include your units when you label your axis. Looking at this table, the range of x-axis is from 0 to 10, and for y-axis, it's from 0 newtons to 1 newton. For our scale on x-axis, we have 6 big boxes, so we can just set one big box as 2 millimeters. And for y-axis, we also have 6 big boxes, so we can just set one big box as 0.2 newtons. After completing the x and y axis, we can plot all the points from the table now. And some of you were asking whether you should draw a straight line or a curve. Well, it should be obvious once you have plotted your points. For this graph, as you can see, we will all observe a straight line. So for a best fit line, just try to connect as many points as you can and extend your line until the end of the graph. It doesn't matter if you have some points which is out of the line or out of the range of the graph, because a best fit line means that you have a continuous straight line and not a graph that looks like this. This is not a best fit line. Let's look at another example of a different set of data which does not start from origin, and if you were asked to draw a best fit line, don't try to force your line trying to go through from the origin, because as you can see here, you're only connecting 2 points and there are many points which is out of the range of the graph. Instead, try to look for a line that connects the most number of points even though it does not start from your origin. And this is another example of a best fit line. If you have any more questions regarding a best fit line, just please ask me in the comment sections below. Moving on. Question D. Use the graph to determine EA, the extension produced by a load of 0.5 newtons. Show clearly on the graph how you obtain the necessary information. So at load y equals to 0.5, draw a straight line until it touches the graph and identify where it connects at the x-axis. For me, it connects at the point of 5 millimeters. According to your marking scheme, any values from 5 to 5.4 millimeters is acceptable. Question 2. A student investigates the cooling of water. Figure 2.1 shows the setup. Again, always take a minute to understand your setup before moving on to answer your question. Here you have a beaker, a thermometer to measure temperature, lid most probably which goes to cover the beaker, and a bench that holds all your apparatus. Question A. The thermometer in figure 2.2 shows the room temperature theta R at the beginning of the experiment. Record theta R. The temperature from the thermometer is 23 and do not forget your unit degree Celsius. Question B. The student pours 200 centimeter cube of hot water into a beaker. He places a lid on the beaker. He places the thermometer in the hot water in the beaker. This is what the setup looks like. He records in table 2.1 the temperature theta of the hot water at time equals to 0. He immediately starts a stopwatch. He continues recording the temperature in table 2.1 at 30-second intervals until he has 7 sets of reading. Part 1. Complete the column headings, and Part 2. Write the times in the first column of table 2.1. To complete the headings, insert your units. For time is in seconds and for temperature is in degrees Celsius. It mentions that it starts at time equals to 0 and continues every 30-second intervals. Question C. Part 1. Calculate the decrease in temperature theta between time 0 and time 180 seconds. And the value for the change of temperature theta would be 17. Part 2. Calculate the average rate of cooling R of the water using the equation R equals to change of theta over change of time, where change of time is 180 seconds, include the unit. So for change of time equals to 180 seconds, you are going to take this whole range, meaning that for your change of temperature, it will be from 92 to 75, which is 17. The value of R that you would get would be 0.0944 and so on. So you can leave your answer as 3 significant figures, which would be 0.0944. And the unit is degrees Celsius per second. Do not forget your units. Question D. A student states that the water cools slowly. Suggest 2 changes to the experiment that the student makes to increase the rate of cooling of the hot water without changing the starting temperature of the hot water. Room temperature remains constant. We can do this by using a thinner lid so that there will be more heat loss towards the surrounding and the temperature will drop faster. Or we could also remove the lid from the beaker. Any logical answer that will cause the heat loss to occur at a faster rate is an acceptable answer. Question E. State one precaution that you would take to obtain accurate temperature readings. Explain briefly the reason for this precaution. One of the most common precautions that you should take while obtaining an accurate reading is to place your eye perpendicular to the scale. This is to avoid parallax error. Or you could also mention any of these precautions. Question F. The student uses a measuring cylinder to measure 200 cm³ of water. He takes the reading from the bottom of the meniscus. Explain the reason for taking the reading at the bottom of the meniscus rather than at the top of the meniscus. This is because there is a very small volume amount of water between the bottom of the meniscus and the top of the meniscus. Question 3. A student investigates the refraction of light using a semicircular transparent block. Figure 3.1 shows a ray trace sheet. Let's understand this setup before answering the question. This is an experiment to observe the ray of light, and we use pins to trace the ray like this. In a ray trace experiment, we will place a ray source from one side and observe the emergent ray from the other side. So let's say if we place a ray box over here, there will be a light source in this direction. And when it passes through from glass to air, the ray of light will bend away from the normal into the observer's eye. That's why you can see 2 pins here to show you the ray of light. Okay, let's get started. Question A, Part 1, consists of 4 bullet points and we will answer it one by one. The first bullet point is to draw a normal NL through the center of AB. Using a ruler, find the center point of AB and draw a line perpendicular to the boundary of AB. And this will be your normal NL. Bullet point 2, continue the normal so that it passes through the curved side of the block. This is the curved side of the block and we have already drawn our normal passing through it. Next, point 3, label the normal NL. You can label it at the top or at the bottom, it doesn't matter. And for your last bullet point, label the point C where the normal NL crosses AB. So the normal NL crosses AB at this point and we're going to label it as C. Done. Question 2, bullet point 1. Draw a line DC below line PC at an angle I equals to 20 degree to the normal and to the left of the normal. So the line DC will fall under this region at an angle of 20 degree to the normal. Let's use our protractor. If your normal is at 90 degree here, so 20 degrees towards it would be at 110. So I'm going to mark X here. From X, I will just connect it to C. And this would be the line DC. We're going to label the other end of this line as D. Part 3, bullet point 1. Mark with neat crosses X the position for 2 pins on line DC at a suitable distance apart for this type of ray trace experiment. Label the positions P1 and P2. Okay, this may sound complicated but it's actually quite simple. Just like how there are 2 pins at a suitable distance falling on the reflective ray, you need to place 2 pins on line DC as well at a suitable distance apart. So I will just refer the distance of P3 and P4 and use the same measurement for P1 and P2. First, let me extend the line DC. So this should be a suitable distance apart between P1 and P2. So mark with neat crosses of X and label it as P1 and P2. Done. Question B. I am going to place question B at the bottom of this page so that it will be easier for us to refer the question and answer it on the diagram. Okay, so question B. The student looks from the position of the eye over here, shown in figure 3.1, to observe the image of P1 and P2 through the side of AB of the block. She adjusts her line of sight until the images of P1 and P2 appear one behind the other. She places 2 pins P3 and P4 behind her eye and the block so that P3, P4 and the images of P1, P2 seen through the block appear one behind the other. Just like how when we observe a fish under the water, it appears to be directly on a straight line from our eye, but actually in reality it is bended in another position. So this is what they meant when they say that P3, P4, P1 and P2 appear one behind the other. The positions of P3 and P4 are shown in figure 3.1. Part 1, the first bullet point. Draw a line joining the positions of P3 and P4. Continue the line to AB. So this is very simple. You just have to connect P3 and P4 and then continue the line until it touches AB. Bullet point 2. Label E the end of line furthest from AB. So if I continue to extend the line, the point furthest from the line AB would be here. So we will label it as E. Part 2. Measure the acute angle theta between the line NL, this, and the line EC, this. An acute angle is less than 90 degree. So we have to use our protractor to answer this question. From our normal NL to the line EC, we will observe an angle of 33 degrees. According to your marking schemes, any answers within the range of 30 to 34 degree is acceptable. Okay, now we're done with all the questions in Part B. Question C. State one precaution that the student takes to produce an accurate ray trace. When performing a ray trace experiment, you should always view your rays from the base of the pin. The next thing is that make sure you place your pins at a vertical position and not like this instead. Also, when you trace your ray, you want to use a thin pencil to get thin sharp lines instead of drawing thick lines like this. If you have any other answers and you want to check whether they are right or wrong, you can leave them in a comment section and I will check it for you. Question D. The student replaces the transparent block on the ray trace sheet in the position shown in figure 3.2. She places P1 and P2 on line DC in the same position used in question A part 3. She observes the images of P1 and P2 through the curved side of the block. She adjusts her line of sight until the images of P1, P2 appear one behind the other. She places two pins P5 and P6 between her eye and the block so that P5, P6 and the images of P1, P2 seen through the block appear one behind the other. The positions of P5 and P6 are shown in figure 3.2. Question part 1. First bullet point. Draw a line joining the positions of P5 and P6. Continue the line to C. So this is simple. Just draw a line connecting P5 and P6 and continue this line to C. Bullet point 2. Label G the end of the line furthest from AB. Well, this is AB, and if I extend this line, the point which is furthest away from AB would be here, and we are asked to label it as G. Though it may sound complicated, always follow the bullet points step by step and you will be able to answer all the questions correctly. Measure the acute angle alpha between the line AB and the line GC. This is your line AB and this is line GC. There are two possible angles here, but since you are asked to measure the acute angle, we will pick this angle because acute angle is less than 90 degrees. So we're going to use our protractor to measure the angle. According to my diagram, I see an angle of 69 degrees. According to your marking schemes, any value from the range of 67 degree to 71 degree is an acceptable answer. Next, calculate the angle beta between the line GC and the normal NL. Well, this question is asking you to calculate, meaning that you do not have to use your protractor, but you need to show your working on how to get the angle beta. From question part 2, we have obtained that the angle alpha here is equals to 69 degree, meaning that the angle beta here would be a total of 90 degree minus 69 degree. So your answer should vary according to whatever value that you got here in part 1. Question E. A student suggests that the angle beta should be equal to the angle of incidence I equals to 20 degree. State whether your result supports the suggestion and justify your answer. Angle beta that we have obtained is 21 degree and angle of incidence is 20 degree. So the student's suggestion here is correct. And for justification, you could say that the value obtained for beta is not too far apart from the value of incidence, which is 20 degree. Question 4. A student investigates the change in current in a conducting liquid as the distance between the two electrodes is changed. The circuit is shown in figure 4.1. Plan an experiment to investigate the change in current in the liquid as the distance between the electrodes is changed. Before planning, let's identify the key variables. So I like to use the acronym I don't care to remember what variables I'm looking for. I is your independent variable, D is dependent variable, and C is control variable. Your independent variable is what is being changed in this experiment, which is the distance between the two electrodes. And the dependent variable is the variable that you're looking to record, which is the change in current. And for control variable is the variable that you keep the same. According to Ohm's law, V equals to IR. If we are measuring the current, we have to keep our power supply constant throughout the experiment. Okay, now we can continue. We are given with 4 bullet points and we are going to plan our experiment step by step using each bullet point. So the first bullet point here asks you to explain briefly how to do the investigation. When you are asked to explain on how to do the investigation, please remember this. I have came up with a method called Monkey Really Rocks, MRR, which stands for Measure, Record, and Repeat. So when you have to explain how to do the investigation, make sure you have these three keywords. You are going to measure your independent variable, which is the distance between the two electrodes. Next, you have to record your dependent variable, which in this experiment is your current. And lastly, do not forget to mention repeat. And what you're repeating here is your independent variable. So you should mention that you need to repeat the experiment with at least 4 other distances. Okay, you're done for the first bullet point. Bullet point 2. State the key variables to keep constant. When they ask you to mention key variables, please mention at least 2 key variables to keep constant. You already have the first one here, which is power supply. And for the second key variables to keep constant, you can mention any one of these. If you have any other answer, just leave it in the comment section and I will check for you. Okay, you're done with the second bullet point. Now for the third bullet point, they ask you to draw a table or tables with the column headings to show how to display your readings. You are not required to enter any readings in the table. So when you are drawing a table, you need to mention one column with your independent variable, including your unit, and dependent variable also showing your unit. If you do not display your unit, you will not get 1 mark for this point. And you're not required to enter any readings in the table. Okay, done. Now with the last bullet point, explain how to use your readings to reach a conclusion. This is a very common point that they will ask you when planning your experiment, and the answer is always the same. You should always plot a graph to show your readings. But if you just mention like this, you will not get a mark. You need to say plot a graph of change in current against distance. So you must always mention the axis of your graph. If you don't, you will not get a mark. Okay, now we can write all of this at our answer space. Okay, I have written this in bullet points form, but in your exams, please don't do this. Make sure you're writing in a paragraph. This is just me writing it in a way that you guys can see how the mark is being given. So for bullet point 1, you have used the method Monkey Really Rocks, Measure, Record, Repeat, and you will get 3 marks over here. And for bullet point 2, for variables to keep constant, you gave 2 variables, so you will get 2 marks here. Drawing a table gives you 1 mark, and displaying your results to reach a conclusion, plotting a graph of change in current against distance between electrodes, mentioned completely together with its axis, you will get a complete 1 mark. So all of this gives you 7 marks. If you want to be safe, you can also mention repeat the experiment for a few readings and get the average reading. You have to mention get the average reading to get an extra 1 mark if it applies. Okay, that's all for this paper. Thank you so much for watching until the end of the video. I hope it was worth your time. If you liked the video, please don't forget to like, comment, and subscribe to my channel. Bye!